Hi, my name is Archit, and this video is part of an assignment from my Psych 1 class at UCO. Today I'll be exploring a highly relevant topic: correlation is not causation. The information from this video comes primarily from lecture notes, with some details coming from the internet. Let's begin by explaining what correlation and causation actually are. Correlation is simply when two variables are related. I like to think of correlation as two variables following the same pattern. When one goes up, so does the other if there is a positive correlation, and the opposite if there's a negative correlation. Causation, on the other hand, is when one variable directly affects another. So, what's the difference? Here are two graphs that depict a clear correlation between two variables. Can you figure out which one actually represents a cause and effect relationship? If you only look at the trends, it is actually impossible to tell which one represents causation. The important thing to remember is that correlation does not imply causation. Let's take a look at what the blue and red graph represents. We can see that it shows a correlation between shark attacks and ice cream sales. Let's think for a moment. Does ice cream cause shark attacks? No, right? Just because two variables follow the same pattern does not mean that one directly causes the other. There may be other factors in play called confounding variables. In this case, the weather is likely a confounding variable, since more people go out to beaches and in the ocean in the summertime, where sharks may attack, and of course, ice cream is consumed more in the summer as well. The graph that actually depicts causation, by the way, is smoking versus lung cancer, which is supported by plenty of scientific evidence. There are many other examples where two things being related does not imply direct causation. Similar to ice cream and shark attacks, ice cream sales and sunburn are also correlated. Once again, the weather is likely a confounding variable, since we consume ice cream more in the summer and get more sunburned as well. Another somewhat humorous example is the correlation between headaches and sleeping with shoes on. The confounding variable in this case is alcohol consumption, which makes you more likely to sleep with shoes on and wake up hungover. A relevant example for many students would be the correlation between SAT scores and performance in college. Performance in college is ultimately a lot more complicated than just your SAT score, as there are many factors involved. A lot of the students who perform well in the SAT also do well in college because they have a good work ethic, making study habits a likely confounding variable. Now that you understand that just because two things follow a certain pattern does not mean that one directly affects another, you might be wondering, how do we actually determine causation? And the only way to determine causation is through experimentation. Experimentation involves adjusting one variable and measuring how it directly affects another. And that is why experiments are very important in the field of science. Well, this concludes the video. Remember that just because two things seem related, it doesn't mean that one thing is the direct cause of another. By understanding this concept, you'll be better equipped to critically evaluate information and make informed decisions, whether you're reading a news article or conducting your own research. Thank you for watching and have a great day.